First thing I want to show you is a couple tricks for evaluating polynomials. So let's make sure we understand what this means, though. We say this word a lot in math. If I say I want to, for example, evaluate this polynomial p of x when x equals -2, what's that mean?
You just plug in -2 into that.
Plug it in, yeah. Value means number in math, and so whenever you see the word evaluate, you always know you're going to be plugging a number in to find another number, right? So we're going to plug in -2 into this function to see what the value of the function is when x is -2. Okay, I want to show you one way to do this using a graphing calculator that's really slick, and it makes this process really easy, is like this. Okay, all you got to do, if this is the polynomial I want to use, and I want to plug in a value of -2, what I can do is I can store the number -2 as x. So I just hit -2, and then see that little button down there above the on? That's for store. STO stands for store. So store that as x, and then I just hit enter. And whenever I pull up an x, it's going to have that value. Then all I've got to do is literally type in that polynomial and hit enter, and it'll put that value of x in for all of the x's. So I could just say 4x cubed plus 3x squared plus 2x plus 1, and hit enter, and there it is. Okay. And if I wanted to put in like a different value of x, then all I would have to do is store, let's say I want to put in 15 for x. I could store that as x, and I could just go up and grab that expression again, pull it down and hit enter. It'd give me the other value when I put in 15. Okay? But the one we want is that one, right? So we wanted the value we get when we plug in -2. That's a pretty easy way to do it if you have a graphing calculator. If you don't, I'm going to show you another shortcut. Another thing we can do is what's called synthetic substitution. So that's what I'm going to show you first here. Okay, the way you do this is you make like a little bracket. Make a little bracket here, off on the left, and then you're gonna leave a row for all the coefficients of the polynomial. The number that goes in the bracket is going to be whatever the number is that you're plugging in for x, right? So that's going to be a -2, and then the numbers that go here are just going to be all of the coefficients of x, and you have to have all of them. You can't skip any. So for example, if the x squared term were missing from the polynomial, I'd have to put a 0 in where the coefficient of x cubed should go, right? So here's the row. For the coefficients. So we'd have 4, 3, 2, and 1. And then I'm just going to I'm going to leave space for another row, and I'm going to put another, just a bar at the bottom, a line at the bottom. And here's how this works. It's really simple. It's a lot easier than the alternative, which would be if I have to put in a -2 and then cube it and multiply by 4 and put in a -2 and square it and multiply by 3 and add those up. There's a lot less of a chance to make a mistake when you do it this way. All you do is whatever the first number is, you're going to drop it straight down so it's going to pop out below the line. As soon as a number pops out below the line, you always multiply by the number in the bracket. So 4 times -2 is what? -8. And then I'm just going to put that number in the second row of the next column and add. 3 plus -8 is what? -5. Okay, a number appeared below the bar, so what do I do? Times it by -2. -2 times -5 is 10. So I put it in the second row in the next column, and I add up. 12. And then -2 times 12, negative 24. And then I forgot to do this, but there should be a box under the last column, underneath the bar in the last column. When I add these up, that's my answer. What's 1 plus negative 24? Does that sound familiar? Isn't that the number we got? Right? So that's called synthetic substitution. The nice thing about it is you never have to deal with any exponents. You're just multiplying and adding, which is pretty simple, right? Okay, so real quick, why don't you guys, if you don't have one, quickly grab a Chromebook and log in. And I want you to go to, well, I take roll. I want you to do one problem. Go to the 6.5 practice and do problem number 1. Okay, so that's synthetic substitution, and the good news is, if you know that, you just did half of what we have left to do. It's just a different context, but exactly the same process. Now, here's the part you got to really pay attention for, though, because this is the part that's a little bit harder. We're going to do polynomial long division. That just sounds hard, and it is. It's not super difficult, but it's a long process. It's so easy to make a mistake. So I want you to close those down completely. You got to watch this very closely, or you're going to be lost. So let's remind ourselves, in order to kind of set ourselves up to learn how to do this with polynomials, let's go back and just remind ourselves how we do long division with numbers. So seriously, you got to close. You will not. This is like one of the things you can't miss. If you miss this now, it's going to be a lot harder for you to learn. So close those things up. So if I want to do long division with these numbers, remember how we do that. Whatever's in the denominator is what goes out in front of the bracket, right? And then whatever's in the numerator goes inside the division bracket. That thing's got a name, but I don't remember what it is. So the 277 goes inside, and then what do we do?
And you see how many times 12 goes into 27?
Okay, yeah, 12 won't go into 2, so we got to move over a digit. 12 goes into 27, how many times? 2 times. Now what?
With 3 left.
So you subtract 24.
Okay, I had to multiply then, right? Whenever a number appears up here, I'm going to multiply by the 12 and get 24, and I subtract. 27 minus 24 is 3. I bring down the 7, and I do it again, right? 12 goes into 37 how many times? 3. And then I multiply. 3 times 12 is 36, and I subtract, and what do I get? 1. Now 12 doesn't go into 1, so we know that's the remainder, right? So how would we write that answer then? We would say that 277 divided by 12 equals 23 plus my remainder of 1 divided by the original denominator, right? Does that make sense? Okay, so that's how we would do that.
What happened to just put the little r?
Okay, yeah, that's the R. Back in the day, you used to probably just put the R1. The R1 is really bad. The R1 doesn't really mean anything. It just, at the time, that made sense because that's where you were in the process, but we're long past that. So now we got to write it as a fraction. Okay. All right, so we're gonna do the same process to polynomials. Right? Yeah, it looks bad, but it's not so bad, I promise you. So we're gonna do the same process. What's in the denominator goes out front, right? So x squared plus 2x minus 5. And what's in the numerator goes inside. But before you jump into that real quick, I got to remind you about something. Just like we did with synthetic division, when we put the coefficients in there, we have to put zeros in. Exactly. So in this case, we've got our 6x to the 4th plus 5x cubed. But now notice we're missing an x squared. So I've got to put a plus 0x squared there. Okay? And then I continue on plus 2x, and finally I get down to the constant, and so I'm done. All right, here's how this works. It's the same process. We're just going to ask ourselves, how many times does just the leading term, we don't have to worry about the whole polynomial, we're just going to see how many times does the leading term outside divide into the leading term inside. Okay? So what are we going to get? How many times does x squared divide into 6x to the 4th? You can literally just write this out. We could just say 6x to the 4th divided by x squared equals what?
6 squared.
6x squared, right? X to the fourth over x squared just gives us x squared. We subtract and we divide like bases, we subtract the exponents, right? So then once we get a number up here, that's our 6x squared. What do you think we do?
Multiply it by x.
Yeah, we're gonna distribute this. We're gonna multiply it by this whole thing, so we're gonna distribute it through, right? And so we're gonna get 6x squared distributed to the x squared gives us what? 6x squared times x squared? 6x to the fourth, and those have to match up, and you'll see why in a second. 6x squared times 2x. 6 times 2 is 12, positive 12, and x squared times x is x cubed. So that goes in the x cubed column, right? 6x squared times negative 5. That's going to give us x squareds, right? So we get negative 30x squared, and now we're going to subtract the whole thing, okay? Now you can see why those first terms needed to match up, because we want those to go away when we subtract, and they do, right? The 6x to the fourths cancel. And let's keep going. So what else do we get? So those cancel. 5x cubed. Now watch how I do this. This is something, it's easy to make a mistake. Sometimes people just do 5x cubed and they add this instead. It's 5x cubed minus 12x cubed. Is how many x cubes?
Negative 7x cubed.
Negative 7. Okay. Negative 7x cubed. 0x squared minus negative 30x squared. Think carefully.
30x squared.
Positive 30. If I subtract a negative, I'm adding, right? So I'm going to get plus 30x squared, and then I just bring these other terms down, and now what?
Divide by the next term.
Go again. Yeah. How many times does x squared divide into 7x cubed? Okay, well, let's find out. So I'll just go up here and make a little more room up here. And we'll do negative 7x cubed divided by x squared equals what? So negative 7 and x to what power? Yeah, the 1. Good, so negative 7x, right? X cubed over x squared would be x to the 3 minus 2. And so that's our next term. Okay, what do I do? I multiply it through, right? Distribute it through. So now the negative 7x is going to get distributed to all three parts. Negative 7x times x squared. What power of x is that going to give me, Tyler? By multiplying x's by x squareds. X cubes. And what's the number going to be? Negative 7 times 1? Okay, so there's my negative 7x cubed. Let's distribute to the next one. X times x is going to give me x squareds, right? How many of them? Negative 7 times 2? Negative 14x squareds goes in the x squared column. And finally, negative 7x times negative 5 plus 35x. And then I'm just going to subtract the whole thing and keep going, right? So what's negative 7x cubed minus negative 7x cubed? Cancels, right? Good. So that's important. That cancels. That's good. 30x squared minus negative 14x squared.
4x squared.
44, because I'm adding, right? Subtracting a negative means I'm adding. You gotta be real careful with those. That's where people make mistakes on this every time. That's if you make a mistake, it's likely to be when you subtract a negative and forget to make it positive. So that's going to give me positive 44x squared, 2x minus 35x.
Negative 33x.
Negative 33x. And then I'll bring down the plus 8, and what do? Go again, right? So now let's ask, how many times does x squared divide into 44x squared? So 44x squared divided by x squared is what? 44. Yeah, the x squareds would cancel, wouldn't they? So I'd end up with 44, and so that's going to be the last term. How do I know this is going to be the last hurrah?
There's no x.
There's no x, right? And so I know this is going to be the end of the line. I'm going to get a remainder or not, but this will be the last time I have to go through it. So when I distribute the 44 through, 44 times x squared gives me 44x squared. 44 times 2x, what's that, 88x? And then 44 times negative 5 is what, negative 220? And if I add all, well, actually I'm going to subtract, aren't I? I'm going to subtract that line, and what do I get? The 44x squareds cancel like they should. 33, actually negative 33x minus 88x. What's negative 33 minus another 88? 121 is gonna be, isn't it? 'Cause I'm gonna get 30 would make it negative 118, right? And then I'm gonna take away another 3. So I get negative 121x, and then 8 minus negative 220 is what? 228. So that's my remainder, okay? So then how could we write this answer up here? So we could say,
Divided by that bottom part.
yeah, so let's write out the answer to this thing, right? So we end up with that. So that original quotient is going to be equal to my answer, which was what? 6, it's right here, 6x squared minus 7x plus 44, right? There it is. Plus my remainder of negative 121x plus 228, and that remains over what denominator?
X squared plus 2x minus 5.
Yeah, x squared plus 2x minus 5.
And so that's your answer.
That's my answer.
So why don't you do the other terms? You only do the x squared as the first term. Like,
Say it again.
if you go up, why do you only do the very first term divided by everything and not any of the other terms? Like
Oh, not the other stuff?
Yeah.
It's just the way we do it.
Oh.
Yeah.
Okay.
Yep.
Where's the negative out front come from?
The negative out front of where?
Like out front of the parentheses.
Out front of here? Because think what we did with long division. It's the same process, right? You told me to subtract the number on the bottom.
Yeah.
Right? So that's what we're doing here too. Instead of numbers, we have polynomials, but I'm gonna subtract. When I distribute the 6x squared through, I get some answer, and I have to subtract that from the original each time. So I always have to put it, whatever I get when I distribute, I'm gonna put in parentheses and subtract the whole thing, okay? That's a big process. I mean, it is a big process, and you gotta be very careful with it and don't go too fast, right? Here's the good news, okay? If we do something like, so I want you just to I'm going to go through this one kind of fast. So I want you to just to watch me do it and make sure the steps sort of make sense to you. Stop me if you have a question. But I want to do this once using long division, and then I want to show you a great shortcut. It's going to make this a lot easier. Okay. So, but you can only do the shortcut in certain cases. It wouldn't work on the previous problem. It's only going to work on problems like this, and I'll tell you about it in a second. So if I do this, I'm dividing x plus 2 into 2x to the 4th plus 3x cubed minus x squared minus x minus 8. Okay, so x goes into 2x to the 4th how many times? 2x. X times what is 2x to the 4th? 2x cubed. So I'll distribute that through and get 2x to the 4th plus 4x cubed. I'll subtract the whole thing and get those cancel, right? 3x cubed minus 4x cubed is negative x cubed. I'll bring down the other stuff. X times what is negative x cubed? Negative x squared?
Yeah.
Okay. I'll distribute that through and get negative x cubed minus 2x squared. I gotta subtract the whole thing. So once again, the x cubes cancel. Negative x squared minus negative 2x squared is like plus 2x squared. Everybody agree that gives me an x squared?
Yeah.
Minus x minus 8. X times what is x squared? No, x times what would give me x squared? X. So I distribute the x through and get x squared plus 2x. I'll subtract the whole thing and get the x squareds cancel. Negative x minus 2x is minus 3x. Bring down the negative 8. And then finally, x times what is negative 3x? Negative 3. Okay? And then I get negative 3. If I distribute that through, I get negative 3x minus 6. I'll subtract the whole thing and get what? The x squareds, or the x's cancel. Negative 8 minus negative 6 is negative 2. So that's my remainder, right? Everybody agree? Okay, now watch how much more quickly I can do this. In fact, I can do it right up here. I don't even need very much room. What happens if I do the synthetic substitution process we just learned? So the number that I'm going to put out front, though, is not 2. I'm going to put the number that goes out front is going to be what I get when I set the bottom equal to 0. So it's the 0 of the denominator. What value of x makes the bottom 0? Negative 2. So I'm going to put a negative 2 out front, and then my coefficients are just going to be 2, 3, negative 1, negative 1, negative 8, and there's my box, right? So bring down the 2. Negative 2 times 2 is plus 3 times negative 2 plus negative 1. 1 times negative 2 times 1 is negative 2 plus negative 1. Negative 2 times negative 3 is 6, so my remainder is, okay, do those numbers look familiar? Where do you see them? Yeah, so the negative 2 works out to be the remainder, doesn't it? But what about the 2, negative 1, 1, and negative 3? I mean, do those numbers right there look familiar in my last answer? What are they?
The coefficients?
The coefficients, yeah, look at that. There they are, 2, negative 1, 1, and negative 3. How about that?
How would you know which exponent goes with which?
Okay, here's how you know. Because you're just going to work backwards. Whatever's in the box is always the remainder, right? The next one over is going to be the constant. The next one's the coefficient of what? X. Next one's coefficient of x squared, coefficient of x cubed. If there were another one, it'd be x to the 4th, x to the 5th, etc., right? So what this means then, this literally is just telling us that we end up with the answer is 2, that's going to be the x cubed. 2x cubed minus 1x squared plus 1x minus 3 plus negative 2 over x plus 2.
I like that one.
Yeah, I like that way.
That's way easier, isn't it? That's called synthetic division. Now here's the kick though. The only time you can do that is if the bottom is linear. So if the bottom, the power of x is 1, it wouldn't have worked on this one because the bottom was squared. So if the bottom is bigger than linear, if it's squared or cubed or something, you have to use this long division technique. Okay. Sometimes you can do a shortcut though. Let's look at one more if we have time. What about something like this? Could I use synthetic division there?
No.
It doesn't look like it, but the bottom can be factored, right? Look at what does the bottom factor into? This is a really good shortcut if you can see this. What does the bottom factor into? What are the magic numbers?
Negative,
They have to multiply to -2 and add to -1, right?
negative 2.
-2 and +1. Okay, so here's what we could do. Think about this. What if we were doing a problem with just numbers? What if I had 12 divided by 2 times 3? Couldn't I do this? Now watch real closely. Oh, hang on. Everybody focus up here. Justin, you guys see this. So I could do, instead of doing 12 divided by 6, I could just do 12 divided by 2 is 6, right? Divided by 3 is 2. Agreed? Okay, so look what I could do here. I could take this problem, I could take the polynomial on top, and I'd write it out as, let me use a different color. So I'd write it out, my coefficients would be 1, -2, what comes next? No. 0, I'm missing an x squared. 0, -3, 2. The number that goes out front, let's do this one first, would be a 2, right? Because that's the 0 of that factor. See what I'm doing?
Mhm. So you'd have to do it twice.
I have to do it twice, but it's pretty easy to do twice. I bring the 1 down. 1 times 2 is 2, plus -2 is 0. 2 times 0 is 0. 0 plus 0 is 0. 2 times 0 is 0. Plus -3 is -3. 2 times -3 is, oh, you know what? Hang on, I screwed this up.
Wow.
Never mind. I thought I had a different problem up here. Okay, ignore that. You'd have to use long division.
So does that mean tomorrow we have a work day?
Yes, you guys get a work day tomorrow.
Thank
Yep.
God. And so we have to have grades turned in by the end of the day, right?